Section 8, Pressure Vessel Construction Code UG General Requirements. In this module, you shall learn about the ASME Section 8, Division 1. We shall also briefly explain Division 2 and compare it with Division 1. There was a section for basic knowledge to refresh your mind, and lastly, our cards of highlights, cue cards of highlights. The source inspector note from ASME Section 8. The Section 8 Division 1 rules for construction of pressure vessel contains the requirements for design, fabrication, examination, inspection, testing, certification, and pressure relief requirements. Division 1 is divided into 3 subsections with mandatory and non-mandatory appendices. The source inspector should be thoroughly familiar with the contents of Division 1 on fabrication, examination, inspection, and testing. Some of the content covered in ASME Section 8 Division 1 that the source inspector should be familiar with includes all definitions in Appendix 3, materials, UG 4 to 15, fabrication, general requirements 75 to 85, inspection and testing 90 to 103, marking and reports 115 to 120, and then welding requirements, welding materials, fabrication, inspection and test, marking and reporting, post-weld heat treatment, radiographic examination, comparing ASME Section 8 Division 1 with ASME Section 8 Division 2. The source inspector need not be thoroughly familiar with the contents of Division 2 for the examination, but the source inspector should be familiar with what the standard covers. In this module, we shall learn about all of the above. Less important clauses from API SIRE exam point of view are either described in brief or grouped together, while only the highlights described here. More important clauses from API SIRE exam point of view are explained in detail. You do not need to memorize tables and figures, just get an idea of what they are about. We shall highlight whatever you need to memorize. Is a container with external or internal pressure of over 15 psi and diameter of over 6 inch. The 3 parts of the ASME Section 8 Division 1 are Part UG for general requirements, Part UW for welded pressure vessels, Part UCS for carbon steel and low alloy steel pressure vessels. UG General. Ultimately responsible for welding, NDT, fabrication and testing of pressure vessel, even if part of it may be subcontracted. Manufacturer shall fill in U1 form, parts manufacturer fill in U2 form to be accepted by the ASME construction inspector. Manufacturer attaches a nameplate with U stamp. After the construction inspector verifies the data report at the manufacturer's plant and authorizes the application of the U stamp. U for general. This is on page 7 of ASME Section 8 Division 1. Non-pressure containing material need not conform to a specification but shall be of weldable quality of welded to the pressure containing parts. Pressure containing material need to conform to ASME Section 8, Section 2, Part D, Subpart 1, Table 1A, 1B, and C, and 3. UG 5, plates used for pressure containing parts shall conform to ASME Section 2, which is for the materials. For forging, forged material used for pressure containing parts should have coarse structure removed by heat treatment, because coarse structure is brittle. There shall be one tensile test for each forging weighing more than 5,000 pounds. For quenched and temper forgings weighing more than 10,000 pounds, at the time of heat treatment, 2 tension tests shall be taken from each forgings. Castings Cast material can be used for fabrication of pressure vessel provided that the allowable stress multiplied by the casting quality factor, EC. The basic casting has a quality factor of 0.8 with just a visual examination, but depending on the type of NDE performed as additional examination, the quality factor can be increased. For example, casting with either a surface finish of 6.3 micrometer RA, or if MT or PT tested, would have a quality factor of 0.85, either of them. If both the surface finish done and MT or PT tested, quality factor would increase to 0.95, and if surface finish done with UT volumetric test or RT, it have a full quality factor of 1, same as base metal. Pipe and tubes. Pipes and tubes shall conform to a specification of material brought again in ASME section 2. So ASME section 2 is all about the materials, different types of materials. A4, B4, part A4 ferrous metal. Pipes and tubes should also be either hydro tested or pneumatically tested for 5 seconds for minimum 250 psi without evidence of leakage. Welding materials. The welding materials shall comply with one of the specifications in section 2 part C, which is for filler metals. If welding material do not come with a test report or certificate, then they should be marked and tagged for identification. Material identified with or produced to a specification not permitted by this division, and material not fully identified should be tested and recertified by the vessel or part manufacturer only and be acceptable to the inspector, so the manufacturer takes the responsibility. Prefabricated or performed pressure parts furnished without a certification mark should be identified, and the manufacturer shall ensure that it's suitable for the design condition. So again, it's the manufacturer who is responsible for this. The traceability of materials received from subcontractor shall be included in ASME certificate holder's quality control system and verified by the inspector. So it's always inspector verifies the material certificate and the material traceability, but it's a manufacturer who is ultimately responsible. The studs shall have threaded portion that is at least 1.5 diameter in length. The use of washers is optional, but shall be of wrought materials. Wrought materials are those materials that are subjected to hot or cold forming, extrusion, rolling, or forging. Rod and bars can be used for fabrication of pressure parts such as flange rings, stiffening rings, and frames for reinforced openings. The chemical and physical properties, heat treatment requirements, and grain size requirements should conform to the approved specification listed in subsection C. The stress values of welded tubing made of plate without the addition of filler metal should be multiplied by a factor of 0.85. So that is the joint efficiency it would be actually. Now use lower joint efficiency of 0.85 rather than full one for welded tubing. Now there are some other also requirements here. We just summarize them from 58 to 64. Materials for pressure parts must be handled in a particular way per the code. For instance, the code specifies that material for parts of the vessel should be laid out and marked in such a way as to easily maintain traceability after the vessel is completed. So it should not be hidden under a weld or under a nozzle or etc. Several techniques for identification marking are allowed and described in these paragraphs. Stamping is the preferred method of marking pressure parts. However, as-built drawing and tabulation sheets are also acceptable. So if it is not, then it should be on the drawing. The material traceability should be reflected. The manufacturer must maintain traceability to the original markings. For instance, when cutting parts for the vessel from plate, the heat number stamp on the plate should be transferred prior to cutting the plate. The record of this marking must be maintained, which will allow positive identification of the vessel parts after construction. If a code vessel manufactured by parts that are formed, such as heads formed from another manufacturer of the head, shall transfer the marking as applies to the material specification that the part is made from. So the same rule applies to the subcontractor for different parts of the vessel. Only materials allowed by the code can be used by the part manufacturer. In addition, part manufacturer must supply a partial data report. Form U2, the marking of the part manufacturer must be present on the part. Form U1, manufacturer's data report for pressure vessels, and Form U2 should be filled in by part manufacturer data report or for subcontractor. The material's original identification marking should be transferred to the vessel's part or noted within a sketch for traceability. So either stamped there on the part itself, or the traceability should be on the drawing or a sketch. All the plates should be positively identified. Die stamping, marking, stenciling. Parts can be repaired provided the inspector approves the method and extent of repair. So it depends on the inspector. Here they mean ASME inspector. Approves the method and extent of repair. The reduction in welding thickness during the forming operation shall not exceed 1 millimeter or 10%, 1/32 inch, or 10% of the nominal thickness of adjoining surface, whichever is less. So you cannot thin it by the welding thickness during the forming operation by more than 1 millimeter. For out of roundness or ovality limit, the difference between maximum and minimum inside diameter at any cross section shall not exceed 1% of the nominal diameter. So maximum 1%. Sharpie test. These are the dimensions of the Sharpie test. As you can see, it's 10 millimeter by 10 millimeter, and the length is 55 millimeter, and this notch has got a 45-degree angle, and the R is the radius of this tip of the notch is 0.01 inch. You don't need to memorize this, just to show the size of the Sharpie test specimen. Sharpie impact test shall be conducted at the minimum design metal temperature or colder, and there shall be 3 test samples minimum. So you might ask you how many test samples for Sharpie. Retest when the average value is below the minimum required for a single specimen, is below 2/3 of the minimum value required. So there are 2 requirements here. Obviously, the average value of the 3 tests should be the minimum required, and also none of the single specimen should be less than 2/3 of the minimum value. Any carbon or low alloy steel with thickness less than 10 millimeter or tensile strength less than 260 MPa do not need an impact test. So heat treatment shall be performed by the vessel manufacturer or under his control. Letter T followed by letter G shall be placed on the place heat treated at the mill. So TG means it's heat treated. Manufacturer shall ensure that WPS, Welder Performance Qualification, Building Procedure Specification, Entity Procedure and Reports approved, authorization and approval of ASME Construction Inspector obtained, ensure that the manufacturer certificate of ASME authorization is valid, material identification and traceability is in place, material test report and impact test report is in place, design and drawings approved, perform dimensional check and produce as-built drawing, heat treatment, subsequent pressure and leak test performed, and manufacturer record book prepared. In ASME Section 8, the term inspector means ASME authorized construction inspector, not API site inspector or any other type of inspector. This inspector is employed by an ASME accredited authorized inspection agency or user manufacturer if pressure vessel is built exclusively for his own use and not for resale. The source inspector has the duty to monitor the manufacturer's quality control system. Inspector should have free access to all the pressure parts during construction and erection. The highlights of the paragraph are as follows for inspection of materials. 1. Plate is the only pressure vessel material that must always have a mill test report or certificate of compliance provided. The inspector shall examine these documents for compliance to the material specification, normally ASME Section 2. All other product form must be marked in accordance with their material specification. For example, pipe marked as SA 106 grade B. All materials to be used in a vessel must be inspected before fabrication to find as best as is possible the defects which could affect the safety of the vessel. The following cases require inspection: cut edges of parts made from rolled plates to be inspected for lamination, shearing, cracks, etc. Material shall be will be impact tested, must be examined for surface cracks. The inspector must assure himself that the thickness and other dimensions of the material comply with requirements of this division. The inspector must verify welded repairs to defects. The inspector must verify that all required tests have been performed and are acceptable, impact tests, NDE, etc. The inspector must confirm that there are no dimensional or material defects, and the inspector must perform internal and external inspections and witness the pressure test. Manufacturer shall ensure that materials are traceable and conform to the specification by obtaining the material certificate from the mill, and the inspector shall verify the same. That is, verify the material certificate and identification mark against the material for traceability purpose. The handling and storage of material by the vessel manufacturer shall be documented in his quality control system such that the inspector can determine if that is the material identified. And all material shall be inspected against possible imperfections such as surface cracks which may affect the safety of the vessel. About marking on materials, identification mark shall be visible and legible and should be transferred to the parts cutout. And examination of surface during fabrication, it should be checked as the fabrication progresses, and dimensional check of component parts shall be checked against design thickness, nozzles, and reinforcement shall be checked for fitness. Inspector should check the dimensions against the drawings. Inspector shall also inspect the completed vessel, including all the vessels at the time of final hydrostatic test or pneumatic test. And again, here the inspector will be an ASME authorized inspector. Maximum allowable working pressure. Maximum allowable working pressure is the maximum allowable pressure at the top of the vessel. Static head. The pressure gauge to read for hydrostatic test is one that is placed at the highest level of the pressure vessel, because the highest point would be showing the least pressure within the vessel, not accounting for the static head. That is the weight of the water that adds to pressure as you go down. That's the highest pressure would be at the bottom, and this pressure at the pressure at the top plus the height of the vessel multiplied by 0.433 psi, provided water is used which has a specific gravity of 1. This is called a static head. Pressure conversion factor is 0.433 psi per feet of pressure. So the maximum allowable working pressure at the top is less than the maximum allowable as you go down, and is the highest at the bottom of the vessel. That is why ASME UG 98 states that the MAWP for a vessel is maximum pressure permissible at the top of the vessel, because if the vessel can withstand such a pressure at the top where it experiences the least pressure during its normal operating condition, then it would certainly withstand the static head as well. But you can have like 3 feet down of the top of the vessel, force 76 psi, and at 34 feet, so there would be 31 feet difference here, deeper. So that's multiplied by 433, and say if you go to 100 feet, then it's 97 feet. So that you should get more pressure at the bottom of the vessel. So MAWP is different at various heights or elevation, being the least at the top and maximum at the bottom. In order to ensure that hydrostatic test pressure at every point in the vessel is at least equal to 1.3 times the maximum allowable working pressure, the pressure gauge is placed at the top of the vessel. If the design temperature is less than the test temperature, then the strength of the material at the minimum design temperature is less than the strength of the material at ambient or test temperature. So practically we have to use they call it the LSR, lowest stress ratio. So what this means that, for example, if you got a material that say at minus 50 degree Fahrenheit has say a strength of 150 MPa, megapascal, or say 70,000 psi, and then at 20 degree plus 20 degree Fahrenheit or 30 degree Fahrenheit, which is the ambient test temperature, or 50 degree Fahrenheit, it would have like 70,000 psi. Now here, because you assume that you have to divide 70,000 divided by 60,000, and that would be the lowest stress ratio. So it means that because you are not testing it at minus 50 degree Fahrenheit, which is assuming to be the minimum design metal temperature, then you have to do this stress ratio to simulate within that pressure. The pressure is same, but the strength reduces when the temperature reduces or the temperature increases too much. Say above 200 degree Fahrenheit, the strength starts reducing for most of the material. Specifically on the lowest range also, it starts reducing. So you have to multiply that lowest stress ratio in order to simulate the pressure with that temperature. So hydrostatic pressure is maximum allowable working pressure into 1.3 into lowest stress ratio. It's recommended that the metal temperature during hydrostatic test be maintained at least 30 degree Fahrenheit above the minimum design metal temperature to minimize the risk of brittle fracture, but need not be above 120 degree Fahrenheit or 48 degrees centigrade. This 30 degree could come in the exam. What's the minimum metal temperature? It would be 30 degree above the minimum design metal temperature, but not more than 120 degree Fahrenheit. That's a cap. Avoid brittle fracture. Painting and coating shall be done after pressure test because they may conceal any possible leak if they done before the pressure test. Pneumatic test. At every point in the vessel shall be at least 1.1 times the maximum allowable working pressure multiplied again by the lowest stress ratio. Proof test to establish maximum allowable working pressure. If due to any reason such as major repair, alteration, etc., the design calculation cannot assure the safe working of the pressure vessel at the maximum allowable working pressure, a proof test is performed to demonstrate that the vessel can be operated at. So this is just how to put it is when you're not too sure, then you just do pressurize it to as a proof load it. So if it can be to standard, then that means once a pressure test is done, so we can always demonstrate that it's safe to do it. It's safe to take the pressure to maximum allowable working pressure. Practically, that's what it says. Test gauges. Code has a definite requirement for test gauges. Direction for location, number, range of gauge, calibration of the indicator is in 100 UG2, UG 102, and the highlights are an indicating gauge shall be connected directly to the vessel. If it's not readily visible to the operator of the test equipment, additional gauge should be used, which is visible for the duration of test. This for safety reason, so he knows what's going on. There is suddenly no surge on pressure for any reason. When doing large pressure vessel tests, it's recommended to have a recording gauge in addition to the indicating gauge. So it can also record it. It's got some stencil, some pen that record the pressure versus time. L-type indicating gauge shall have a range of about double, preferably double the maximum test pressure, but then the range should not be less than 1.5 times, nor more than 4 times of the test pressure. Digital gauges having a wider range may be used as long as they provide the same or greater accuracy of the dial gauge. All pressure gauges shall be calibrated against the standard dead weight tester or a master gauge, and gauges must be calibrated anytime their accuracy is in doubt. Normally the calibration is annual. NDE acceptance criteria shall be as per ASME Section 8. Remember that NDE procedure is written according to ASME Section 5, but the acceptance criteria is in ASME Section 8. ASME U marking is for user, also called U stamp. U1 form for complete pressure vessel by the complete vessel manufacturer, and U2 is for the part manufacturer. Required marking overview. Being applied to vessel's nameplate or directly to its shell are described in this para is important information. Often a vessel's data report is lost, and the only information that is available is the one that found on the nameplate or the shell itself. In some cases, the nameplate is missing or sandblasted, not readable. The following is a listing of what is required by the code to be present on the nameplate. Official code U or UM stamp. If inspected by the owner user of the vessel, the word user shall be marked on the vessel. Name of the manufacturer, maximum allowable working pressure, and at what temperature it is. It should be mentioned that maximum allowable working pressure, because pressure is directly related to temperature. Minimum design metal temperature at what pressure, again the converse of that. Manufacturer serial number, the year build, type of construction used for vessel must be marked directly under the code symbol by the use of appropriate letter, such as arc or gas welded is W, pressure welded is P, brazed is B, and resistant welding is RES. If a vessel is built using more than one type of construction, all shall be indicated. If a vessel is in a special service, the lettering as shown below must be applied. For example, lethal service is L, hand-fired steam boiler is UB, direct firing DF, non-stationary pressure vessel MPV. You don't need to memorize these figures, it's just for your information. That's why we didn't highlight them. The maximum allowable working pressure must be based on the most restricted part of the vessel, the weakest link, and the gauge placed at the highest point during pressure test. When a complete vessel or part of the vessel of welded construction have been radiographed in accordance with UW 11, the marking shall be as follows. RT1, when all pressure retaining butt welds other than B and C associated with nozzles and communicating chambers that neither exceed MPS 10 nor more than 1 and a 1/8 inch thickness have been radiographically examined for their full length in a manner prescribed in this. So full radiography of the welds, then is RT1. The exempted category or category B and C butt weld it performed may be recorded on manufacturer data report. RT2, completed vessel satisfy UW 11 applied. RT3, complete vessel satisfy spot radiography. RT4, when only part of the vessel satisfies any of the above. A separate section follows, which is devoted to the meaning of RT marking. Letters HT must be used when the entire vessel has been post-welded treated. Letter PHT when only part of the vessel, and hence the word P, heat treated. Code symbol must be applied after hydro and pneumatic test, or the nameplate after the pressure test is applied once authorized by the ASME inspector. Parts of vessel for which partial data report are required shall be marked by the parts manufacturer. with the following part: name of the manufacturer, and the manufacturer's serial number. All required markings must be located in a conspicuous place on the vessel, preferably near a manhole. Certificate of authorization and certification mark is provided by the ASME, so the manufacturer and repair organization for vessel and valve can use the ASME symbol. So the manufacturer should have a quality control manual and quality control system in place, audited by the ASME representative, and then they award them an ASME U stamp, and that together with the ASME authorized inspector's review of the documents and witnessing of the pressure test and traceability of the material and NDT reports, then the ASME U stamp nameplate can be affixed and they can call it ASME pressure vessel. Either a nameplate is attached, stamped directly to the vessel. Additional nameplate, if attached, shall be marked duplicate. So always remember, if the nameplate fall off or there is another nameplate for whatever reason, it should be named duplicate. This is about the details of nameplate on UG 119. An additional nameplate may be used if it is marked with the words duplicate. The pressure vessel should wear line U stamp. So you can see the U and what pressure at what temperature and maximum allowable working pressure, if it's external or internal, temperature, minimum design metal temperature, manufacturer serial number, name of manufacturer, and year built. This is a typical U stamp nameplate. It should contain name of manufacturer, year built, ASME stamp, the U stamp, maximum allowable working pressure at temperature, maximum temperature of minimum, maximum allowable working pressure at minimum temperature, and minimum design metal temperature. Data reports. A data report shall be filled out on form U1, U1A, or U1P by the manufacturer, and shall be signed by the manufacturer and the inspector. Manufacturer shall keep a manufacturer's data of at least 3 years.